Okay, so this is the Unit 7 Review Solutions Part 2. So this is the second review that I've given you. I'm going to be breaking this one up into two pieces like I did the last one, just to keep the video a little bit shorter. Okay, so let's talk about this. So this first one asks us to find x and y, and it says don't use any trig, which is fine. We're not going to use any trig here. What we're going to use instead is we're going to use the idea of similar triangles. So I want to remind you, there are a couple different triangles that you are given. So these are basically the most commonly used ones. So let me give you these two triangles right here, and then I'll erase this. So one triangle where this angle is 60 and this one is 30, and of course this is 90, has the following ratios. Okay, it has the following side lengths. Okay, so if I have this triangle, they're all going to be similar to this one triangle right here. So if this is a side length of 1, then this is a side length of √3, and this is a side length of 2. Okay, so if we're looking at a 30-degree triangle, we can use this one. If we're looking at a 30-degree angle, or if we're looking at a 60-degree angle, like in example A, right? If I'm looking at example A, then this is the perfect triangle to look at, because that means this other angle, I think you'd agree, would be 30. The other triangle that's really important is our 45, 45, 90. Okay? So this is 90, this is 45, and the other angle is 45 also, which means this is an isosceles triangle, so 1, 1, √2. So so if we have a 30, 60, 90 or a 45, 45, 90, any triangle that we have that has those angle measures are going to be similar to these. So there's a couple ways to use these. So let's look at example A specifically. So I'm going to get rid of this. I'm just going to kind of go through a process here. So I'm going to draw a similar triangle. And again, I don't need to do this, but I just want you guys to see what's going on. Okay? Since this is a 30, 60, 90 triangle, I know that it's going to be of this form. So if this is 60, like in the example, right, then this is 30, which means this angle is 1. Sorry, that length of the side is 1. This length is 2. And this length is √3. Okay? Now remember, this triangle right here is similar to this one. So what can I do? Well, I can set up a proportion, and I can say short side is to short side as, well, let's solve for x. √3 is to x, and then I can solve that. So I get x equals, why is that a 7? Oh, yeah, I'm sorry. Couldn't figure out why that was a 7. I was looking at the wrong triangle. So that is 7 √3. Okay? And then if I want to solve for y, I can do the same thing. So let's see. I'm going to use, I'm going to say 1 is to 2, right? So I'm going to go and do the same thing I did last time. I'm going to say 1 is to 7. So 1 is to 7. Actually, let's do this below. So 1 is to 7. Short side is to short side, as hypotenuse is to hypotenuse, as 2 is to, what is the other hypotenuse? Y. So solving this, we get 2 times 7 is 14, which equals, 2 times 7 is 14, which equals y. Okay? So our two values are x equals 7 √3 and y equals 14. Now, that's kind of the concept behind it. Okay? But I want you to know there are some shortcuts here that we can take if we feel comfortable. And I'm going to be as I go through these, I'm going to be kind of going through both ways so that you see the shortcut. Okay? So again, I can always set up similar triangles like I did before and like we've done. But if I look at this triangle right here, right? And I look at the ratio of the sides, notice this side right here and this side. So the hypotenuse is twice as large as the small side, right? So in this case, right, if this is my small side and this is my hypotenuse, and the hypotenuse is twice as large, then we know y has to be equal to 14. No need to set up our similar triangles. Same thing. I know, if I know this small side is 1, right, and this is root 3, well, 1 times root 3 is root 3. So in other words, if I take this number and I multiply it by root 3, I'll get this. So 7 times root 3 is 7 root 3, which is, again, what we got there. Again, no similar triangles needed. So let's go and see how this works. Let's do this again. So I'm going to start with coming up with our values for x and y. And then what I'll do is I'll go through and actually solve it using similar triangles. So let's go find x. Okay, well, again, let's look at the triangle we're using. We're using that 30, 60, 90, right? So we're using this triangle again. And what do we know? Well, we know that the long side, so let's see, 1 times root 3, 1 times something equals root 3, right? So we always multiply, in order to find, what did we do in the last example? In order to find x, we took 7, we multiplied by root 3. Well, now we have this number. How do I find x? And you're probably saying, well, you divide by root 3. And that's exactly what we do. We say 12 divided by root 3, okay? Which, of course, we can simplify as 12 root 3 over 3, which is 4 root 3. Now, let's go find y. Now, the nice thing about y is going to be easier, right? Because remember, we now know the short side. Why am I not drawing? There we are. We now know this side. And we know the hypotenuse is twice as large. Well, if the short side is 4 root 3, then y has to be 8 root 3. So we saw that worked, but let's go and do, so that was the easy way. Let's go and do the similar triangles way. So I'm going to do the same thing that I did last time. By the way, one of the things you can also do is you can use the ratio of the side lengths of one triangle to the ratio of the side lengths of the other. And here's what I mean. So I'm going to look at my small triangle, and I need to find, I already have my long side, so I'm going to go find my short side. So I'm going to say, so I'm going to use the short side and the long side. So I'm going to say 1 is to root 3. Notice how I'm using I'm using triangle 1, if we want to call this triangle 1, and then this is triangle 2. The first ratio is just involving triangle 1. Now let's go to root the second triangle, keeping the ratio the same. So what was it? It was short to long. Okay, well, we don't know the short, but we do know the long. So solving this, we get 12 equals root 3x, which means 12 divided by root 3 equals x, which is exactly what we had here. And of course, we could simplify. Okay, in order to find y, we could do exactly the same thing, right? So I could say, so let's see, 1 is to 2 using the short triangle, or triangle number 1. 1 is to 2 as, what are we doing? We're doing, actually, yeah, sure, why not? 1 is to 2 as 12 root 3. Whoops, actually, I'm going to use this value that we found right here. So as 4 root 3 is to, whoops, I wasn't x anyway. I see that. It was y. Excuse me. As y. And solving that, we get 8 root 3 equals y. So the big thing I want you to take from this is we can use similar triangles if we're kind of stuck, but there's always kind of an easy way. If you recognize what we do to these sides. If I recognize the hypotenuse is always twice as large as the short side, so if I tell you the short side is 5, then you know the hypotenuse is 10 if it's a 30, 60, 90, right? If I tell you that the short side is 7, then we know that the other side is 7 root 3. Okay, so let's keep on going here. Let's see if we can do this without setting up our similar triangles here. So again, let's go and grab this one though for reference. Okay, So this is again a 30, 60, 90. So what do we know? Well, we know that the hypotenuse is twice as large as the small side. The small side is x. So x has to equal the hypotenuse divided by 2, which equals 6 root 2. And then we know y has to be equal to the short side times root 3. So 6 times root 2 times root 3, which equals 6 root 6. Okay? Then let's do our last one here. So this triangle is a little bit different here, right? This is a 45, 45, 90. So our ratios for this one, right? So this is my triangle here. It's going to be 1, 1, root 2. So in other words, we know that y has to be 9, right? Because the legs are equal length. It's an isosceles triangle. How do we find x? Well, we take 9 and multiply it by root 2. Easy peasy. Okay, let's keep on going here. Let's go find these. Okay, so this was very similar to our last one. So let's go and grab that triangle again, since we're using that 45, 45, 90. So let's see what we got here. Okay, I think you would agree x and y are the same length, right? So when I find x, I find y. So let's see. We know that the hypotenuse is equal to the leg times root 2. So in other words, I could set up an equation. I could say x times root 2 equals 12, right? Because we know this times root 2 equals the hypotenuse. So I can kind of say this times root 2 equals 12. Then I can solve for x by saying x equals 12 divided by root 2. Is that the one? No, we did root 3. So simplifying that, I multiply both by top and bottom by root 2. I get 12 root 2 divided by 2, which equals 6 root 2, which also happens to equal y, right? Because they are equal. Okay, let's keep on going. Let's see what we can do. For letter F, I think you'd agree, this is an isosceles triangle, right? So in other words, I know we don't need it, but I'm just going to put it down right here. This side length is 14 root 2. The hypotenuse, right? If we take this side and multiply by root 2, we get the hypotenuse. So 14, so this thing right here is going to be equal to 14 root 2 times root 2, which is 14 times 2, which is 28. Okay? I'm going to kind of get rid of this stuff right here. So that length is 28. Now, what do we have? Oh, we have a 30, 60, 90 triangle. And we happen to have that the short side of that triangle, is 28. What does that mean the hypotenuse is? Well, the hypotenuse has to be twice as much. So it has to be equal to 56. And what does the long side have to be equal to? Well, it has to be equal to the short side times root 3. So 28 root 3. Okay? Let's see what we got here. I want to kind of check. I think, I'm going to do a few more here. I think I'm trying not to take too much time, but let's go on to the trig stuff here. Okay, so now these are trig questions. So I want to remind you, with the trig stuff, we have to remember, let's think about what ratios that we have. So we have 3 ratios. We have sine of some angle. So I'm going to call that angle, I'm going to call that name of that measure of that angle, I'm going to call it theta. And that equals the opposite, which in this case, I think you'd agree is x. And I'm just going to call this side r, even though we don't need it. So sine is x over r. Cosine, actually, let's use the number since we're doing it. So sine of 25 is x over r. Cosine of 25 is going to be adjacent. So if you don't mind, I'm going to call this y just for now. That's y over r. And then tangent of 25 is going to be x over y. For this particular case, right? If I label it this way, this is the way it works. So tangent is opposite over adjacent. So let's see what we have. We want to solve for x. Well, let's see what I know. I know the opposite and I know the adjacent. Which one's that? Oh, that's tangent. Would you agree? So I'm going to say the tangent of 25 equals x over 14. So 14 times tangent of 25 equals x, and then we can solve for that. So I'm going to plug that into my calculator because I have no idea what that could possibly be. And I get x is approximately equal to, it said to the nearest tenth, so 6.5, whatever our units are. Okay, let's keep on going. So next one, what do we have? Well, I think you'd agree we have the opposite side and we have the hypotenuse. So which trigonometric function involves the opposite side and the hypotenuse? Oh, sine, right? That's opposite over hypotenuse. So in this case, actually, I'm going to put those, I'm going to make that a little clearer here. So opposite, hypotenuse, adjacent, hypotenuse, opposite, adjacent. Okay, just for our reference here. Okay, so let's see. 68, so for this one, we want to find x and y. So in order to find y, I'm going to say, oh, let's see what we got here. I'm going to do 68. I'm going to say the sine of 68 equals y over 15. And you might be saying, well, why sine? Well, because sine involves the angle, the side opposite, and the hypotenuse. I was giving 15, so that's perfect. So I get 15 times sine 68 equals y. So 15 times sine, where's sine? Sine, 68. So y equals, I get 13.9 units. And then let's find x. So let's see, x in this case, right? X is going to involve the adjacent side and the hypotenuse. So that is cosine. So I'm going to say the cosine of 25 equals the adjacent over the hypotenuse. So 15 cosine of 25 equals x. 15 times the cosine of 25 equals, so x is approximately equal to, looks like 13.6. By the way, these should have been approximate signs. Not a big deal, but let's be precise. Okay, these are going to be our last two for this first video. So let's see what we got here. We were asked to find x. What are we going to do here? We're actually asked to find x and y. I'm looking for the degree now. So let's see what we got. I think you'd agree we have the opposite and we have the adjacent. Those are the two numbers that we have. What trigonometric function works at? Oh, tangent. So I can say the tangent of x equals 7 over 8, opposite over adjacent. Now, in order to do this, the way we solve this, as you should know, is we take the arctangent. And what that means is I'm going to say the arctangent of 7 over 8 equals x. Okay, so that's how we solve these. So on my calculator, I'm going to go find that arctangent button, which for me is the same button as I was using for tangent, but I'm using the shift. So I'm saying shift, and then I'm doing 7 divided by 8. So shift arctangent, okay? And I get 41 point, what did they ask us to go to? I think just the nearest tenth, so 41.2. Now remember, what is our units here? This is an angle measure, so this is 41.2 degrees. Let's go find the value of y. Now you might be saying, can't I use Pythagoras' theorem to find y? And the answer is, yeah, you could. If you want to, absolutely. But I'm going to instead, I'm going to use that 41.2, and I'm going to use sine. So I'm going to say the sine of 41.2 equals 7 over y, because why not use it, right? So y times sine of 41.2 equals 7. So y equals 7 divided by sine of 41.2. And let's see what we get there. So I said sine of 41.2 Whoops, I messed up. Let's try that again. So it is 7 divided by sine 41.2, and that gives me approximately, right, because this is an approximate value, 10.6, whatever our units are. Okay, so we found y. Last one for this section. Let's go find our different values. Let's go find x and y. So first off, we should recognize that this is an isosceles triangle. So in case I need it, I think you'd agree this has to be 5, right? Because this is a 45, that smaller triangle's a 45, 45, 90. That might be useful. Why might that be useful? Well, I think you'd agree that if I use this side and this side, I have a tangent. I can use tangent. So I can say the tangent of 22 equals opposite over adjacent, which is 5 over what is the length of that long side? It is 5 plus y. Okay, let's go and solve for this. So I'm going to say I multiply both sides by 5 plus y times tangent of 22 equals 5, and then I'm going to divide by tangent of 22. So 5 plus y equals 5 over tangent of 22. So y equals 5 over tangent of 22 minus 5. So in my calculator, how do I clear this? Let's do it. What do we got? So I get 5 divided by tangent of 22 minus 5. And that gives me y is approximately 7.4 units. Okay? Let's go find x. So x is going to be pretty similar, right? Except in this case, I can use sine. So I can say the sine of 22 equals 5 over x. So that one's easier. So I can say the sine of 22 equals 5 over x. So x times sine of 22 equals 5. Divide both sides by sine of 22, and I get x equals 5 over sine of 22. And that is 5 divided by sine of 22 is x is approximately equal to 13.34. Okay? Let's see here. I am going to stop the video there just because it's gone on a little bit long, and then I'll have a part 2 up later.